Cool.
All right, take it away.
All right, well, howdy, everyone. Welcome to TAMA Datathon 2020. I'm super excited to be able to give this lesson, and it's been awesome seeing you all super active on Discord, and we're really happy with just like the number of people that came, and we're all super hyped over here, so we really appreciate your guys' involvement. So to get started, just a quick overview of how this lesson is going to go. What we're going to do is go over just a little bit of data wrangling. I know the class is called data wrangling, but we're really just going to focus on pandas most of the time. So we're going to talk a little bit about where to get data sets. So we'll talk about just different places to get data sets, like the Google dataset search. Talk about Kaggle, and then we'll show examples of how you might go ahead and find a data set with information that you're interested in. We'll then kind of just dive into pandas straight from there, and we'll go over how like the different main data structures within pandas work, which is like the series and the data frame, and we'll talk about how to manipulate those and play with those and do some cool stuff. And by the end, at the end, we'll kind of leave, I think, 5 to 10 minutes or so of times for questions. And so I think, George, you'll probably just cut me off if I go too long. So yeah, let's get started. So what we're going to do is we're going to jump into an IDE called Google Colab. Given that you guys have probably been interacting with Datathon, you're probably all familiar with it, but if you're not, here's how you would get to a Colab instance. It's all on the web. So you might Google Colab. And if you search Google Colab, you get this link here, Google Collaboratory. And if you click this, you'll get the option to probably sign into a Google account. And once you've done that, you can, let me minimize this. You'll get the option to create a new notebook. So I'll create a new notebook, and I'll call it, click up here, call it Data Wrangling. And Google Colab's really interesting. So it's basically a web wrapper around Jupyter Notebook or Jupyter Lab, which is a very popular data science notebook software. So what makes Jupyter Lab interesting is that you can run code, and then all of that data kind of sits in memory, and then you can go and run other pieces of code, and you can jump back and forth and do all this stuff, and it makes it very easy to test and get new data and then run an algorithm on different data. So it's very helpful when you're trying to test things and play with data quickly. However, all of this is running in the cloud, which is great. So Google actually provides not a super high-powered GPU with every single instance of a Google Colab. So when you connect, when I click this button, connect, it actually connects to Google servers, and I have access to, you know, a certain amount of like CPU and even some GPU usage. So if I'm training models, I can actually do some bigger batches than maybe I could even do on my own laptop because I have access to some hardware that Google's provided me. Awesome. So with that, let's jump into the wrangling portion. So I'm just going to quickly show you guys 2 cool websites. So if you Google for Google Datasets Search, there's this link here, Google Dataset Search, datasets research.google.com. And if any of you guys have played with Google Scholar, this is very similar. So Google Scholar makes it very easy for you to find scholarly like journals and papers. So if you're doing research for a project, you're probably using Google Scholar. So this is kind of the equivalent of that. That said, for like all the data sets here are not necessarily like Google Scholar in that they're probably good. You might have to do your own vetting to make sure you're not getting data sets that are totally like bogus or something like that. Just make sure you do your research. But it makes it super easy to find them. So let's say I was interested in finding a data set on the coronavirus. So I might just search corona, if I can spell coronavirus. What we'll get here is a bunch of different websites. Like this is the World Health Organization, the CDC, as well as some other, I guess, big name health organizations. So if I come down to CDC, it gives me a link to go ahead and explore their website. And this is an example of how you might kind of go down the rabbit trail of how to find a data set. So let's say that I'm interested in examining the rate of fatalities in Texas. So I might, this is a bit morbid, but I might come down and see the CDC lets me click on Texas. Okay, so it brings me to the Texas Health and Services website. And so I'm interested in learning more about COVID in Texas, so I click the COVID-19 link. And if I'm going too fast, just let me know. So we're here under COVID-19, and then there's this link here that says additional data. That sounds like what I'm looking for. So I click additional data, and then turns out there's like 4 links here: fatalities over time, cases over time, new cases over time by county. And so if I click any of these, in fact, I'll just click this one right now, and it'll give me the option to download this Excel file. I don't want to do that actually. I want to get that Excel file and throw it into Colab. So what I'm going to do is I'm going to right click and I'm going to click, let's see. Okay, I'm used to Chrome. I think copy link location should do the same thing though. And then I'll come back. If Zoom will get out of my way. One second. Hide video panel. Go away. There you go. Okay, cool. So what I'm going to do is I'm going to say, and I'll explain what this code means in a minute. First of all, import pandas as PD. And then to run a cell in Colab, you can press the play button. I normally press Shift and then Enter. You can also press Control and then Enter, whichever works best for you. The difference between Shift Enter and Control Enter is that Control Enter leaves your cursor in the same cell. Shift Enter creates a new cell below you or just moves you down a cell. So if you want to run like 10 cells in a row, you might just hold Shift and then press Enter, Enter, and Enter. But if you just want to run the cell you're in, Control Enter is probably the best. And then we're going to go ahead and write a bunch of code, and then I'll explain what this does. Read Excel, paste the link, and then we're going to display the data frame. So another feature of Colab and JupyterLab in general is if you put a variable at the very bottom of your cell and you just run the cell, JupyterLab will, Colab in this case, will go ahead and print a kind of a nice pretty version of that variable for you if it can. So if I run this with Control Enter, should go ahead and get the Excel file from this website, and notice we have an Excel file inside of Google Colab, which is super awesome. Now, if we're looking at this, we might notice that this doesn't look super pretty. We've got all these unnamed headers here up at the top, lots of nans, which stands for not a number, as well as what appears to be the real header of the data frame. So if we're looking at this, and we recognize like, shoot, okay, the header really should start here because it doesn't look like there's any useful information right here. So what we can say is, if we come over here, I can say header equals 2. And what that does is that sets the header of this data frame to row 2, so 0, 1, 2, and then this will become the header. We can see what that looks like by pressing Control Enter. And there we go. That looks pretty good, right? So we've got a header with county name, fatalities, and all this stuff, and what looks like a bunch of values.
Good question. Whenever I do import Panda as PD, I get an error that says module not found, no module named Panda.
Are you running, well, if you're saying Panda or Pandas?
That might be it. That might be it. Let me see.
What was the thing you put at the end of the, what was the parameter you put at the end of read Excels again to get rid of the header equals 2? Okay, thank you.
No problem. Cool, okay. So yeah, This is, again, and we'll go through in a lot more detail how Pandas works and some of the code here. So I'm not going to go super into detail here. Something that we might want to do is, a second here. I'm working on a small computer. If we come down to the bottom, looks like we have a pretty good setup. There's like this unknown value here, but I think I'm just going to leave that alone for now. The old version of this file, I'm working off of like notes that I did when I did a class in the summer, and this file has changed. So I think I'm going to leave the code as is right here, and we should be good. So that's an example of how we did some data wrangling. We went to Google Datasets, which is a great website to go and find real data. We searched for some data, we followed the rabbit trail of links, and then we found some good data for us to use in maybe a TAMU Datathon project. So that's one place that you could use to find more data. Another great place to go is Kaggle.com. And Kaggle.com is a data science competition and dataset hosting website. They actually host their own version of JupyterLab as well. It's very similar to Colab. So you can open up these instances and have access to like basically your own computer in the web where you're running your own code, right? So if you go to Kaggle.com, you can mouse over here and go under data. You can find lots of really cool, crazy data sets. Like for example, I was looking up Spotify data sets the other day, and I think, let me just search Spotify. There's a couple ones that I thought were really cool. You can lose hours just going through this. Spotify's worldwide daily song ratings. And in, I'll full screen this. And Kaggle datasets gives you this really nice, like they'll give you the title, obviously, of the dataset, and they'll even go through like, here's a quick description of like what the dataset is and how you might use it and stuff like that. And then if you come down, it'll give you details about each of the columns in the data set. So like artists, it looks like Ed Sheeran and the Chainsmokers are fairly popular. And so you can go through here and it'll create a graph that matches the type of data in that particular column, which I think is really cool. So Kaggle is also a really great place to get data sets. One problem with Kaggle is that you have to either go through this weird API key exchange between Colab and Kaggle to get Kaggle datasets into a Google Colab. There's a way around this. You can actually just download. So if I were to click the download button here, that's a fairly large file. But I could download the data, and then I could upload it to Google Drive and then share from Google Drive. And then there's a way to create a link from that link, and I might post details about that later if you're interested. But you can pull something from Kaggle into a Colab notebook. And that's like one way you can do it. You can run all this locally too if you want to, and then you can just like reference the path to the file if you're running this locally. But back to our original Colab, we talked about Google Datasets, we talked about Kaggle, and now we're going to jump into Pandas and how to use Pandas to manipulate data. And we'll go through like the basics of those two data structures, which are the Pandas series and then the Pandas data frame. So let me pull this guy over here again. So I need a new code block underneath this one. So I can either just run this one again with Shift Enter, or I can press this button to say plus code. So it'll give me a block below it. And in this block, I'm going to write s equals pd dot series. And I'll explain what this code does. And then I will print the series. So I run that block. So we can see here is that a Pandas series looks like some sort of column of values, 1, 3, 4, and then it's got this other row right next to it called index, A, B, C, D. So if any of you guys are familiar with the concept of a dictionary in any sort of programming language or like an unordered map maybe, or any sort of map, I guess, you're probably really used to the concept of writing something like this, right? Where A maps to 1, B maps to 3, C maps to 4, and so on. So it probably would come as no surprise if you could grab a value by saying S at A, and this would return probably 1, which it does. And in fact, if I were to say D, it would return 2. So Pandas series is really just an array of values, and it has this index, and that index goes to that particular value. So Pandas series is pretty simple, just an array of values, and then an index that goes along with that. If I didn't specify index, it would give it an automatic index, which would be what you would expect in a regular array. So now if I said S at 0, this looks like I'm accessing a regular 0 indexed array, right? So like 0, 1, 2, 3, you know, you could interface with this series the same way that you probably would with a list in Python. And they're the same thing. Or at least they have the same interface, right? So I'll go back to the way that this guy was. And run that. Cool. So there's a bunch of, and one of the, I guess, the reasons to use Pandas is that there's a bunch of functions that kind of come with using a series that makes it super easy to like quick get a result. So if I wanted to get the sum of everything in this series, I might say s.sum. And it adds all the numbers together, which is really cool, super fast. I don't have to write a for loop and then keep track of the sum and then like add the numbers, right? I can just write a single line and it does all of this for me. And there's a bunch of functions. There's like sum, I think there's like counts and the number of like different values, and you can do all this sort of stuff just straight once you have a series. So it's super useful. So if you can get your data into a series, you call one of these functions, you can do some quick analysis. Okay, so not much to say about the series. That's about it. And we're gonna move on to the Pandas data frame. So the Pandas data frame is basically a table. So if any of you guys have seen, okay, you guys have seen Excel files before. So basically a Pandas data frame is an Excel file. Or CSV if you're more used to that. It's just a table of values, but another way to think about a Pandas data frame is a collection of series that have the same index. So I'll go ahead and write some code here, and to save you guys some time, I'm going to go ahead and post this code in, go ahead and post this text block in Discord. So give me 1 second here. I'm curious as to how screen share is going to work, but hopefully this isn't too bad. There you go. I sent into the data wrangling channel on Discord just a code block for you guys to copy and paste in your own notebooks. And we'll come back to our regular file. And just because I'm curious, George, how did that look? Because I'm pretty sure you guys lost what I was doing there for a second.
That looked fine.
We just saw the collab the whole time.
Okay, that's what I thought. I just wanted to check to make sure. Cool. Okay, so we're going to go ahead and copy that code and run it, and then we'll talk about what's exactly is going on here. Okay, so this looks kind of like a dictionary, right? We've got this opening curly braces, and then we've got these names. So each of these names corresponds to the header for a particular column, right? So like this header name clearly goes along with Karis, Bruno, Mara, and so on, right? And I think it's fairly easy to see the pattern here where you say the name of the header and then the values in the column, and then the same process repeats. We'll talk about this in a second, but it's a list of red, brown, blonde, brown, so on and so forth. Weight, birth date, kind of a similar structure here where we basically say here's the header, or you can even think about it as like the name of the series and then the values in that series that go along with the same index, which I think is a cool way to look at this. And you'll see why that's important, because if we access a column or a row in a Pandas data frame, it returns a series. So if I were to say students, students at name, this would return a Pandas series. So it looks a lot similar to this guy up here, right? Returns a Pandas series where it has that index and then the values. And then you could run the same functions and analysis that you would do on a Pandas series once you grabbed a single column. Cool. So I'm gonna write some code here. We're gonna actually import Numpy. You guys have probably seen Numpy before. So students of hair color equals numpy.nan. All right, it's cool. So if we run this, what we get is a hair color column that is, and I'll actually comment this out first so we can see that effect. And then I have to print students. So if we run this code, we basically filled the entire hair color column with nan values. And I think that's fairly self-explanatory, right? Students of hair color equals numpy.nan. So we kind of grabbed numpy's nan, I guess, object and populated that in hair color. And then with this code, we can see the use of this function loc. I guess it's not really a function, it's like some sort of accessor. It allows us to access items within this data frame. And loc allows me to input the rows that I'm interested in accessing. I think I can access either a single one, so if I were to run this again and just say 0, it would only access one, or I can also pass in a list so that it'll access multiple. And then I want to do this to the hair color column. And so it'll go 0, 3, 5, and the hair color column equals red. And so we can see 0, 3, and 5 got set to red, right? Pretty straightforward. Okay. So we're just going to move on. But before I move on, I hope I can remember the difference here. I need to mute Discord. To access items within a data frame, there's a couple things that are different than you would expect. So if you're coming from a classical, give me 1 second to mute Discord. I apologize. I don't even know if you guys can hear those alerts, but they're distracting me. So I'll just quick mute that. Mute server for. Cool. So if you're coming from like a classical computing or computer science background, you're probably used to the concept of a two-dimensional array, where you go to the row and then you go to the column, right? So you would have two indexes. So you could say students at 0 at like 2, and just run that. And then data frames get all mad at you. Pandas like, what are you doing? And that's because these aren't really, and they shouldn't be treated as two-dimensional arrays. Pandas data frames are doing so much more in the background. You should generally try to access a column and then a particular row within that column. So it's actually kind of the opposite direction that you would think of if you're used to two-dimensional arrays. You can also use a couple other different accessors. So if I say iLocation, I believe iLocation, I'm going out on a limb here, I'm pretty sure this is, if you wanted to use the same, like, if you want to go row and then column, this is the way that you would do it, specifically with just indices. So if I say iLocation 2, and then iLocation, see if that gets mad at me. Okay, it doesn't. So I went to row 2 and then column 2. and I can prove that in fact goes in that direction. Row 3, column 2, right? 0, 1, 2, right there. So if you want to actually run this like a regular, row and then column, you have to use iLocation instead of location. Location's a little bit more powerful. If you're interested, go and do a little bit, just search up loc versus iLoc on Google, and you'll probably get a pretty decent explanation. It's a little confusing, but once you get used to it, it's not too bad. Okay, moving on. Also, are there any questions so far? I've kind of been talking for a while. Anything that I can clarify?
Can you go back up a cell? Because you said loc, you write the columns before you write the rows.
Yeah.
But it looks like you wrote the rows first on that.
Yes. Yeah, that's a good point. I think I don't know, location does a bunch of stuff. I think if I say location at hair color, it'll go ahead and, okay, it literally wrote it at the bottom. So maybe location does do, I may have gotten that mixed up. I'm kind of forgetting, it's been a while since I've actually like forced myself to use these. Most of the time when you're interacting with this, you'll use just like the column name, and then you'll access the row because you get kind of used to that workflow. I might have to look into the difference between loc and iLoc because I'm blanking on them. They're a little confusing. So I may get back to you guys about that. But okay, we'll move on. And I think maybe the difference between loc and iLoc was iLoc is supposed to be using just indices, whereas loc takes in strings and operates a little differently. So I think that might be one of the main differences. Okay.
Also, can you show that the Google Drive thing? Like how do you connect data sets from Google, upload into Google Drive, and then access it from Google Colab?
You want me to show the Kaggle download, upload to Google Drive, and then pull that into a Colab?
Yeah, Kaggle or any data set, like once you upload it to Google Drive, how do you access it from Google Colab?
Okay, I didn't go over that just yet. If I have time, let's save that question for maybe the end, since I want to get through a couple other things here, and then we'll go over that. Well, I will get back to that question because that's a good question. Awesome. Okay, so if I say students, we're just going to move on here. Data types, we'll show you that you can kind of view the different types of data types that are, actually, let me run this one time. One more time. It's claiming these are all objects. That's interesting. Okay. Oh, no, there you go. I had to like reset it. So when you say students.dtypes, it goes through each column and it will tell you what type of, what data type makes up the values of that column. So for generic strings, it just considers them objects. However, it was able to recognize weight as int64s. And datetime, it knows our datetime objects, namely, and we'll come back to this, because we told Pandas to interpret all of these strings in this list as datetime objects. So by calling this constructor, it took a list of strings and turned them into an array of actual Pandas datetime objects, which you can do more with, right? So you can probably take a datetime object and subtract, a number of days or number of seconds, and you can do more operations. You can't really do those operations on a string. And the Pandas categorical constructor here is kind of interesting. So I think what it does is it takes the different string values and it does some other like association on them. So it knows like, okay, there's so many red, there's so many brown, there's so many blonde. And I think when we come down to group by, you'll see how that affects the way that we can perform operations on a data frame. Cool, so we got data types. We can also change the data type of an object or a column. So I can say students.weight equals students.weight.asType float 64. And then we will print, oops, the data types. So notice that our weight column changed from int64 to float64. And this is another point to make about data frame functions and when you're performing operations on data frames. Very rarely will a function actually perform an operation on the object itself. So notice how I said students.weight equals student.weight.asType float64. That's because asType float64 as a function returns a new version of the column. It doesn't actually change student.weight's column by itself. You have to reassign that back into students.weight. Most of these functions have an option. If you really want to do something in place, you'd say in place equals true. And if I were to do this, we would get the same effect. Okay, asType is one of the functions that does not have in place equals true, but most functions have the option to do in place equals true. And we'll see that if you want to like drop rows, if you say in place equals true, it'll do the operation on the data frame itself. Whereas if you didn't have in place equals true, it'll return the new data frame without those rows back into like whatever you're assigning that to.
Quick question.
Go for it.
I was wondering if students.weight, is that the same as doing students bracket and then calling the weight column?
Yes, yeah, good catch. That's exactly the same. So if your column name is a single word, so it doesn't have spaces in it, you can use the nomenclature of calling it with the dot operator. So I can say students.weight instead of having to say students at weight equals students at weight as type float 64. So these do the exact same thing. So students at, thanks for catching that, is the same thing as students dot weight. And this applies whenever your column name is a single word. If I were to have a column name that like had a space, which I can do, so people names or something, if I were to run this, I couldn't come down here and say students dot people names. Like that just wouldn't work because there's a space. All right.
Thank you very much.
Yeah, no problem.
Also, just going over the last part, like when you say in place, so basically when you're doing asType, it's automatically replacing that column, or that if you don't do in place, then it replaces the column.
If you say in place, so maybe I need to do an example of this. So let me make this clear. So I'll create a new one. And basically, if I were to say students dot drop students dot tail 2. So basically, what this line means is drop the final 2 rows of the student's data frame. If I were to run this, why is he getting mad at me? Names, hair color, weight. Okay, hang on a second. Let me rerun all of these. It's getting mad at me. Okay, it's still getting mad at me. Okay, names, hair color, weight, birth date not found in access. That's weird. Give me 1 second. Drop students.tail. Oh, sorry. I have to say .index. So, okay, yeah, so students.tail2 gives me the last 2 rows, and then I get both their indexes. And so this would be the equivalent of saying, like, drop 7 and 6, right? Notice that we didn't, if I were to access students right under this, students still has 9 rows. So when I ran this line, it returned something with only 7 rows, but it didn't actually change the student's object. It returned a new one, and students has remained the same. If I run this line with in place equals true, and then I reference students, we can see that students actually changed. So that's the difference between in place equals true and in place equals false, right? Is if I say in place equals false, it just returns the new object. If I say in place equals true, it affects the object itself. And for most of the time when you're doing work in a in like a collab or something like that, don't say in place equals true unless you really want to, because if I wanted to, like, normally what happens is you actually delete something permanently and then you try to rerun the column, but that stuff doesn't exist anymore, so you just delete more. And usually that's not the process that you want to do. Because if I were to keep calling this with in place equals true, I would just get smaller and smaller and smaller, and that's not actually what I wanted. So I'll say students equals students.index. And now that I've permanently changed the object, I have to come back up and run through all of this again. Cool. All right, so we have 7 rows here. And does that answer your question, by the way?
Yeah, it thanks.
Okay, awesome. Cool. All right, so moving on, I have to scroll back down to where I am in my setup here. Okay, yeah, so we also have a couple really cool functions that we can just call on a data frame. We're going to go through a couple of these. One of them is just describe, except I can't spell. Students.describe, cool. So students.describe goes through and finds the column that it can, like, describe the most. I believe there's a way for me to force this to do all. Let's see. Exclude, none, include. Okay. I think if I say include, if I say all, we'll do that. Yeah, okay. So if I say include all, it'll give me a description for every column in the data frame. So for names, there's 8 different names. We noticed that there's 9, actually there's 10, excuse me, rows, but there's only 8 unique names. And we can verify this because there's, looks like there's 2 Maras. And so that should, I think, yeah, that should account for it, I suppose. Anyway, yeah, so there's duplicates. So the number actually unique is 8. The top one is Kiva, so I guess there's multiple Kivas. Or is that I think, okay, that's interesting. So I don't understand exactly how describe does some of these, but some of these are really useful. So for weight, for example, it might make more sense to have like a count, like a mean. A mean doesn't make sense for names. Like, how do you calculate mean? I don't think that's very well defined. And then it'll give you some quantile values if you're a statistics person. These might be really useful to you.
If you're looking for some of the columns but not all of them, would you do include equals and then like a list of necessary columns, or would there be another way to do that?
Repeat that question. Sorry, I couldn't hear you.
How would you how would you select just like multiple columns but not all of them?
Multiple columns, but not all of them?
Yeah.
Well, I could say this is one way I think I could do it. So students.describe returns a data frame. Like, this is an actual data frame, so I can work with it like I would a data frame. So I think I can say location at, and then I think I can give it an array of column names. And so let's say I wanted hair color and weight. I'm pretty sure this will work. I'm kind of going out on a limb here. Some of these are a little obscure. Okay, so maybe if I say this, yeah, okay. So I can just do it like that. So I could grab hair color and weight from the description. So what's cool about that is this returned data frame, and then I accessed 2 columns, hair color and weight, in that data frame. And that gave me this. So does that answer your question?
Yes, thank you.
Okay, cool. I really need to go over that location function. That's really throwing me off. It's kind of bothering me. I'll probably figure it out after this. It is kind of weird how those work. Okay, so we're going to talk about another function that you can perform on a data frame called group by. And group by is super powerful, but it's a little bit difficult to understand. So I've got this image that I'll show you guys. And again, all of this is in the collab that I sent in the Discord channel. So I pull this up. It's all mad at me because this needs to be a markdown file. Okay, well, let's talk about that for a second. So Colab can handle Python code, and it can also handle what's known as Markdown, which is a basically what it sounds like. It's a Markdown language, right? So, or I guess markup language. I don't remember. Anyway, it's basically you can write text, but you can also format it by using certain codes. Like for example, if I say this turns into, it grabs this picture and shows it, and then it has a link that's associated with it, right? So I can run markdown text, and then it'll render it for me. And so you can use this to make really nice notebooks where you have like images, and then you can add like lines, and you can format text and stuff like that. So you can make some really nice organizational structure to and visual structure to your notebooks as you're writing them. And so that actually is very helpful to your presentation. So for example, it might be worth looking into, and I'm not going to cover it in this lesson, but how to write markdown documents, because anytime you press plus text, you can write a full-blown markdown document in this block and like format it and everything, and it can look really great. And that can really help your presentation when you are presenting tomorrow. So yeah, little datathon tip right there. Okay, so let's talk about this image right here. So group by, if you tell it to group by a particular column, what it will do is find the different sets of values within that column, and it'll make the data frame basically rearrange itself where those rows kind of that have the same value in that column come together. So I'll write some code here. Students.group by hair color. And I'm curious, before I run this, if anyone wants to take a stab at what this will return. And I'll show the data frame right here. Wait, okay, I don't think oh wait, shoot. Let me run this original one. Okay, so looking at this one, and I said group by hair color, and then hair color.count. What do you think that will return? I'm curious if anybody has any like intuition about this. So I'll copy this cell and I'll bring it down here. If anybody wants to take a stab, I mean, you could probably run this yourself, but also if you want to take, sometimes it's helpful to like look at a line and then try to figure out what it will do before you run it. Okay. Basically what it does is when you run it, it returns a series of counts for the different values. So there's 2 red. We're only seeing the head of the data frame here. There's obviously a lot more values. If I were to just print students, there's more. But there's 3 blondes, 5 browns, 2 reds. And so what happened here was we grouped the hair color column. So all of those rows kind of like separated, and then the values like came together that had the same hair color. And then each of those groups still is like a data frame. So you can access the hair color column for each of those data frames and then perform what's known as like an aggregation function. So I can call count. There's different aggregation functions like sum. So if I were to group things, if I were to say weight, right? So this would group things by hair color and then grab the weight column and then sum it up. So we can see which hair color has like the highest weight. We can see here that if you were to add brown, which makes sense because there's more browns, Brown has the largest total sum of weight. I think there might be a mean function, which if we were to run, gives you the mean weight for each of these groupings. So there's a lot of cool things that you can do with a group by.
Quick
And
question.
yeah,
Sorry,
sure.
sorry to interrupt you. So whenever I go ahead and like control enter it, I don't get any values. I just get the series name, weight, D type, float 64. Is that because I'm printing something I mean, the statement that you wrote is the same one that I had in terms of like, you know, at the end being weight.sum.
Yeah.
But I don't know if I'm printing something wrong up there.
Yeah, go ahead and rerun. So copy this cell from the top and rerun the cell and then run this code. That might be your problem. Also, for those of you who are familiar with SQL, if any of you have done SQL programming in the past, you'll start to recognize a lot of functions from SQL have parallels over in a data frame or in Pandas, and that's by design. Data frames are supposed to act like tables, and you can group them together and then perform aggregation functions on those. You can also, and we'll see in a second, you can merge data frames together too. And you can perform inner merges, left merges, right merges, you know, whatever you're used to in SQL, you can probably do with a Pandas data frame. And that's because data frames are really designed to handle manipulation of data. I have minimized my like Zoom thing, so I can't tell who was talking, but did you get this working?
Oh, yeah, I did. Thank you.
Cool, awesome. Cool, all right, so let's run another group by function. I think it was kind of stress the point here. So we're gonna group by, and so we can do multiple group bys. So we can group by one item, and then within each of those groupings, group by another column, right? So I can group by hair color, and then after I group by hair color, I can group within each of those sections, I can group by name. So, and this is supposed to be a function. Run that, oops. Did I spell something wrong? Oh, names, apparently. Okay. Cool. All right, so we can see that the hair colors got grouped together here on the left-hand side. So like everything in here, we know every person here has brown hair, and every person from here on down has red hair. And obviously the same goes for blonde over here. And then we grouped these by name and then got the count for each of those. So again, we don't lose information as we kind of group these together. It's just the table becomes more and more segmented. And the way that you would get to a particular segment is by going hair color and then to a particular name. And then that's still a full data frame row. So you can call hair color.count on that particular data frame, and that'll give you the count of the number of rows there, which is the number of people with that name with that hair color. Did that make sense? That might be a little confusing, but if you think about it for a second and you just imagine these rows kind of coming together and that they still have the same number of columns, I can do anything. I can say hair color, I can say weight. It doesn't really matter. It'll give me the same result. I think, did that give me the same result? I think so. Okay, cool. Awesome. Are there any questions about that? Because I know that can be a little confusing, but that's like super powerful. You can do like these multiple levels of groupings, and then once you've pivoted off of these values, you can perform some analysis, which is, I mean, I'm stressing this point, but it's super powerful. You can do a lot of that.
What happens if you just do students.group by without any other methods? Or...
So Pandas is doing a bunch of fancy stuff in the background, and it just gives you this group by object.
Okay.
So it's you can't actually do anything or like view the data once you've done some sort of grouping. You have to basically call an aggregation function. So I don't have to access a particular column once I've grouped everything together. I can actually run an aggregation function, I think, on each of those data frames. So notice we pivoted on a hair color, and then we pivot based on each of the names, and then we did describe on like each of those sections of the data frame. So it'll give me the description for each of these subsets. We've just been doing it to the where we grabbed a particular column and then we performed our aggregation. But you can, once you get to here, you just have to do some function to take each of these groupings and perform the same function to each of them. And if you have a function that can apply equally to all of them, you can get something interesting. Cool. Any questions about that? Okay, cool. All right, we'll move on. All right, there's a couple others. I do want to get to merging. I realize, I think we go until 6:15, right, George? He's still there. It's all good. Okay, we go until 6:15. Okay, so I'm going to just show a couple lines here, a couple other things we can do. Oops. So we can tell students.names, which are normally just treated as objects, treat them as strings, and then run the lower function on each of those strings. That's what this line does. So convert all of these to their lowercase form. I can do something similar. I can say students.names.string.replace E with like a hyphen or something. Just kind of cool. So you can see all the names with an E. I replaced the E with a hyphen. So you can run like a regular Python string function like replace, strip, which will strip white space, and a couple other things on all of these items without having to write a for loop, right? So think about how you might do this if you weren't using a data frame. You might have to write, you know, a bunch of for loops to like iterate through all the values and then call strip on that. And so if you're really used to how these data frames work, reading a single line both keeps your code clean, and if you know how Pandas works, this can make reading your code a lot easier too. Okay, so skip that one. We'll just go to students.apply. So students.apply is kind of similar. So we would kind of like applying a function to an entire column here. But there's a more general way to do an apply. So we can write a function. In this case, it's going to be a lambda. So it's just a function that's defined in place that takes row and then does this to row. It returns this. I think that's it. Oops, lambda row, row name. Make sure I type that all.
Names. I think it's the
Oh.
names.
Thank you. Good catch. Awesome. Okay, so notice what we did was we applied a function to every row of students. So we were able to access an entire row, which is why we have this function that takes in a row and returns row at names plus the hyphen plus row at hair color, right? So that's pretty cool. And then I think this will be where we end. I have one more thing to show, and that's how to do a Pandas merge. So I'm going to send a piece of code in Discord really fast. I appreciate you, Jessica, for posting something about iLoc and loc in the Discord. Cool. So go ahead and copy that into your notebook. So I'll do so here, and go ahead and run that. All right. So what we're going to try to do here in this next portion is we're going to try to merge RGB colors with the student's data frame. So we know the student's data frame has like names and hair colors and weights. And what we want to do is for every hair color, we want it to have its R, G, and B value for that particular hair color, right? So it's almost like we want to go through every row in the student's frame, go through every hair color value, and where the hair color matches the color here, I want to like basically append these values, right? So let's take a look at that. Right. So once we get a hair color and a color match, we want to append that row basically to the maybe a new data frame, right? So here's how we do that. We'd say merged is equal to PD pandas dot merge students RGB colors left on hair color. Yep, I think that's it. Oops. It's RGB colors. Forgetting my S's. All right, merged. Here we go. And that did exactly what we expected, right? So where hair color and color matched, we appended that entire row from color into with the row from students into like a single row, and then added that to our new data frame, right? And we can see that we said left on hair color, so that's the column that we're going to match on in students, and then color, which is the column that we're going to match on in RGB colors. And by setting this up, we're setting up, all right, wherever these guys match, add them together, add that to the new data frame. And again, if you come from a SQL background, you probably are familiar with merges and group bys and stuff like this. This is the same concept. You can say how, and you can specify a particular type of merge. So if I did a, like notice green here, there's no green hairs. So if I said how, and I said right, and I ran that, we noticed that there's like a new row here. There were no matches for green, but we still have to have every row from RGB colors. There was no match, so it just has these like basically equivalent of null values in that particular row. So it was able to match on all the other hair colors, but it wasn't able to match on green. But because this is a right join, I might be able to pull up a Venn diagram. SQL joins image, right? Yeah. So if we look at these different SQL joins, this is a right join. So we have to include everything from set B and where it intersects with A, right? Yeah, cool. And I think that's it, and we're out of time. We'll probably skip to questions. I think I have one more thing I can show. Right. I'm not a fan of having two columns in my data frame that have the exact same values, right? So if I go back to the way that this was before, and I believe that this was an inner join, which means that you only join on values that match, and you exclude values or rows that don't match in either the left table or the right table. So that would be an inner join. But let's say I want to get rid of the color column. Let's walk through that. So I might say merged equals merged dot drop, and I want to drop color. And this value is a reference to a header. So I need to say drop something on this axis, right? So rows are axis 0, columns are axis 1. So I'm going to say axis equals 1. And then if I print merged at the end of this, oh, it's because I ran this. So let me run this, and then run this. Right, and now we have no color column. I think that might be it for time. Cool. Well, thanks guys for listening to that. I have another class, I think that starts at 6:30, and I'll take this time from 6, where we are now, 6:06 to 6:15, answer any questions you guys have, and then I'll be back at it at 6:30 for a visualization class. Stop sharing.
So I have a question. In the data set which you showed for just in general in Google Colab, so if for a cell, if I don't like, I keep the data in a cell, and if I create a new cell and try to run code on the previous data which I imported or I downloaded into the data frame or whatever, will that data frame will be available to me, or do I have to run that code once more?
I'm going to be completely honest, I didn't catch all of that. Can you repeat that question? I will.
So let's say there are like we are using multiple cells for your Jupyter notebook, right? You have
Okay.
different cells. So
Sure.
in one cell, like you are accessing the student's data frame which you have created or whatever. So
Sure.
if I'm doing any modifications on it or something else, and and it is possible because I have imported that data frame. But in the next cell, if I don't mention, like if I don't specify the data frame again and just say that it's the student dot and try to do some operation on it on a different cell, will it be possible to do that?
Sure. I mean, I'm pretty sure that's what we've been doing, right? So I created the data frame here, let's say, so students, and then I referenced it here. And I didn't have to redefine it or anything. Like once I run this cell, in memory, it's holding the student's data frame, and I can access it in any other cell in any direction. So I can actually go above this guy. I can write a code, and if I say students, I can access this data frame, which is actually the guy that was defined down here. So once I run something, it just stores it in memory. And then any other cell that I run anywhere else in the Colab or Jupyter Lab or whatever you're running this in, have access to that same variable.
Okay, so basically I have to run it once before I can able to access it.
Yeah, sure. Yep.
I think I faced a similar problem, like especially in the beginning when you said import the Numpy. So I went on and put the Numpy in the big first cell because it looks symmetric. You did all the import at the beginning.
Right.
But when I tried to access the Numpy in the bottom, I was not able to. I might have forgot to run the cell. That might be issue. Thanks.
Okay, no problem. Yeah.
I have a question.
Sure.
So you use it, I think you use Lambda, right? So could this also work on like another data structure type like MongoDB, for example?
Repeat the end of that question again. I'm sorry. For whatever reason, I'm not hearing these questions very well. What was that?
So like since you use it on Lambda, could I also use like this application on, let's just say, MongoDB? Because I recently worked with that over the summer, so I was just wondering, could I also use this data with MongoDB?
Well, I don't think Lambda here is the same thing as what you're referring to. I mean, you can probably write Python code to interact with a MongoDB like database, right? But what's going on here is this is what's known as like an anonymous function. So the way I could rewrite this is I could say, define a function which I'll call foo, because I don't actually care about the name, that takes in a row. And what it does is it returns this. So what's really going on here is I'm saying apply foo to every row in the data frame. So go down the column axis, right? So for every row. So what I did here is I passed, and I can run this just to prove this to you. So same result. What's going on here is I don't actually care about the name of the function because I don't plan on using the function anywhere else. So lambdas in Python and in most other programming languages mean anonymous in that they don't have a name and you can write them inline. So the way that you would write a lambda function is you say lambda and then the parameter that you would take in row and then what you return, which is this. And so this amounts to the same thing as just typing foo there. Does that make sense? I think you might be getting confused. I think MongoDB, I'm not familiar with MongoDB, but if MongoDB has some like maybe lambda feature of some sort, these probably may or may not be connected, but maybe if you're writing code in MongoDB and you can write lambda, then that's the same concept, but that's what a lambda is. I hope I didn't go too far around answering your question there.
No, you're good. I think I understood like where you were trying to come from. So yeah.
Okay, cool.
What does the
Wait,
access do in that function right there?
Sorry, repeat that.
What does access do on apply?
Oh, on apply? So I guess my interpretation of this is that axis tells you which axis to go down. It's kind of weird. I personally am a little bit annoyed by the fact that, so axis 0 does mean row, and axis 1 means column. So I think when you say axis 1, what it's telling you is to apply it to every row in the down like the column direction. That's my interpretation of this. Does that make sense? If I were to change this to
Yes.
0, then I would have to write lambda column because what I would be passing into this anonymous function is a column. But this is the way that it works. Yeah, I hope that answers your question.
I have two quick questions.
Go for it.
Why could you not, or could you take out lambda row colon right there?
Why can I just delete this and run this?
Yeah.
No. The main reason is that what needs to go here is a function. And the function, like, there's a particular type of function that apply expects. Apply expects a function that if you're saying axis 1, takes in a row and returns something else. So that has to be a function. You can't just say row names, because I'm literally saying I want you to name, like I could say lambda A, and then I can change this to be A and this to be A. So I see what you're thinking there, because we're using the word row. And if you're going down, you should assume that like the name could just be rows. But the fact of the matter is that that name isn't special. It could be anything. And so
oh, because you're assigning it right after lambda.
yes, lambda expects a value passed into it, which we're calling A.
Okay. I thought, I was figuring like rows were already like something you could just use from wherever.
Yeah.
Not that. Okay, that makes a lot of sense. And then my other question was, you said whenever you permanently change the data frame, that you had to go rerun it, the original instance of it. Why do you have to do that?
So, I mean,
Because I'm like confused of why, like how you would know to do that. Because like in my brain, I would just think that it would, it changes students up to that point.
so this is, yeah, I think this is coming back to our discussion about in place versus like not in place. So if I'm going through and I'm doing stuff to like students, and I guess the example was so I have students here, right, which it does a thing, and I come down here and I say students dot drop, and then I'm going to drop students dot tail to, oh, that's some group there. Right, and so this drops 2 rows. And so I'm not quite sure I perfectly understand your question, but this isn't a permanent, like it doesn't change students if I don't tell it to. Like if I were to say new students is equal to this, students isn't changed, but new students is students minus those last two rows.
I'm just a little confused on why, because you were saying you had to scroll back up and refresh it at the top. And
Yeah.
I'm not sure why you
Oh,
did that.
sure.
Or why you needed to do that.
If I do this, if I say students, which is students in memory, is equal to students.drop, those two.
Mhm.
And then if I were to print, actually, okay. If I were to print students now, students itself has only 7 rows. So let's run this.
Right.
Let's run this code again. I could run that cell, but just to make the point, let's do this. Okay, now there's 5. There's 3. Now there's 1. There's 2, right? Or
Right.
okay, sorry. There was 4 and then 2. I was looking at the value. But if you're reassigning your operation back into the data frame itself, then it changes it permanently. Does that make sense?
Right. Yeah.
Okay.
Yeah, like I understand that part. I just wasn't understanding why you were like scrolling back up to the top and then refreshing it and coming back down.
Yeah, that's because I had literally done this. I had messed up the original data frame by reassigning it back into itself. And so I realized I wanted the original again. So I had to go back up and refresh the value in memory by reassigning it to the original value.
Oh, okay, I see. Because you're just trying to undo it. It wasn't because you needed that to make the code continue to work on there. I think I understand now.
Okay.
All right, thank you.
No problem. I think we're a little over time. I think there was a question about Google Drive and Kaggle. To be completely honest, I haven't yet done that. I'm pretty sure I know how to do it. But if I may go ahead, I'm probably going to go take a quick break because I have to teach another class at 6:30. But I'll make a note of that and make sure that I get, I don't know if you're still in the call, but the person that asked that, I'll make sure that you get an answer about that. So how to Kaggle to Google Drive. Awesome. All right, well, thanks everybody for coming. If you're interested about learning a little bit about visualization using the package Seaborn, I'll be covering that at 6:30. Happy hacking, and I guess I'll see you guys later.